And what twin studies do is they compare monozygotic to dizygotic twins. What does that mean? How do I do that? What's a monozygotic, dizygotic twin? I'm sure we're all familiar with this, right? Monozygotic are identical twins, one egg splits in two, exactly same DNA. Dizygotic, two eggs, both fertilized at roughly the same time. No different than you and any one of your other siblings. So if I want to tease out the effects of genes from the environment, or to see if a trait has a genetic component, and I know this relatedness in genetics for identical and non-identical twins, what could I do? How could I discern this effect? Is there something way I could do it? Yeah. Okay, I could put the monozygotic twins in, so adopt them out. Not very ethical. Well, not experimentally. It will happen. It will happen. And that's the best way to do it, by the way. But if I just want to look at normal twins who are not, I don't mean normal, that being adopted is not normal. I'm just saying that the majority of experiments that get twins are often not two identical twins adopted. That's quite rare, right, to get. So what could I do with regular twins based on what I know about monozygotic and dizygotic twins? Keeping in mind, you ever heard of concordance rates? Go ahead.
You can compare, like, on a given trait, if it is genetic, then the identical twins should be more like than the fraternal twins.
And that's exactly it. Someone else had their hand up? Same thing? Okay. And that's what we do. So you look at the monozygotic twins compared to the dizygotic twins on some trait. Here's the thing. When a twin is born, if they have a certain disorder, let's say schizophrenia, and the other twin also has schizophrenia, they are said to be concordant, all right? And concordant, of course, is in agreement. If one twin has the disorder and the other one doesn't, they are said to be, what do you think? Discordant, all right? So concordant and discordant. So we use concordance rates to determine the genetic basis of a trait. And here's how it works. If the concordance rates, and a concordance rate is usually a correlation. So let's say the concordance rates for schizophrenia are 85% for monozygotic and 14% for dizygotic. What can I deduce from that statement? 85% concordance rates in monozygotic, 17 or 14% in dizygotic. Yep. Must be a genetic component because the concordance rates are higher, 85% versus 14% in the monozygotic twins. They have the same DNA. So when one has it, 85% of the time, let's say, the other one also has it. In the dizygotic twins, there's a less chance that if one has it, the other one also has it. So less of a genetic component, right? You with me on this? And that's what they often do in these concordance rates. So I just want to show you here. This is one for IQ changes. These here are monozygotic twins, and of course there's two lines because it's two people, right? So one twin is in red, the other twin is in green. And as you look at this graph, going from 3 months all the way up to 6 years old, their IQ rates are pretty much similar. A little bit of a gap here at 12 months, but 12 months old, I mean, that's irrelevant. So going up here, and they're pretty much identical all the way through. In fact, research has shown time and time again, cross-culturally, that if you give two twins, monozygotic twins, a IQ test, it's almost like giving the test twice to the same person. That's how close they are. And also on many personality measures, that if you were to give a test to a person on, let's say, the 5-factor, the big 5, the personality inventory, they score almost identical on all the traits. So a huge genetic component to these kinds of behaviors. Over here are dizygotic twins. And as you can see, the variability here is huge. The only reason that we have different scales here, and they qualify this down here, is because of the differences in the scores. But you can see clearly that the monozygotic are more superimposed than the dizygotic twins. So again, indicating, based on concordance rates, that this may have a genetic effect. Problem, again, is these two assumptions that you make when you talk about concordance rates. What do you think it means, equal environments assumption and representative assumption? If I'm making these large statements about monozygotic versus dizygotic twins, what huge assumptions, and these major two, am I making? Yeah. Okay, number one, I'm trying to, I'm making the statement or making the assumption that monozygotic and dizygotic twins are treated equally in the environment. Are they? What do you think?
Not necessarily.
Okay, what's the difference? What's the difference in a dizygotic and a monozygotic twin in the way that we treat them?
Well, with monozygotic, they look this.
They look the same, which means we may dress them the same. People are more fascinated by them. They react to them differently. They're always going to be the same sex. Good point. Exactly. They have to be the same sex. It's the same egg, right? So we can't really, with 100% certainty, even with concordance rates, say that this is due to genetics because we have a still, we're making an assumption that they are equal when it comes to everything, and they're certainly not. So that's the equal environments assumption. The other one is the representative assumption. What's that mean? Remember, I'm making statements to the general population based on findings on twins. So what is the problem here in the representative assumption? What do you think it means? What does research aim to do? To generalize to the larger population. Can I then do studies on twins and then make generalizations to the general population? No, it's a biased sample, right? This is a group of people that are different than everybody else. And there may be something about being a twin that can, monozygotic or dizygotic, that makes you different than the regular individual. So these two major assumptions also are confounds or are problems that you have to think about when you are trying to decide or conclude that this is actually a genetic factor. You can't all the time do this. So then we have what somebody just mentioned is the adoption studies, which is one way to rule out the environment completely. Because when you have a child adopted to a different, to a non-biological parent, then if that trait develops and it is similar to the biological parent, then you can with more certainty say it's genetic because the environment is no longer an issue, right? So what they look at is correlations between the adoptive child and the adoptive parent versus the adopted child and the biological parent. And time again, research shows that the adopted child becomes more alike the biological parent as time goes on. With IQ, when a child is first growing up, the IQ may have some environmental impact from the adoptive parents. But as a child gets older, it starts to look more and more and more like the biological parent. So again, indicating that this has a high genetic component. Now, the best research would be identical twins reared apart. And there are studies that have actually done this, and they look at the effects of the same person, really, the same DNA, monozygotic twin, one being brought up in one area, one being brought in a completely different area, and if they both develop the same behaviors, traits, or in this case, a disorder. And then you have more conclusive evidence that it may have a high genetic component.
At least, I remember like last year, there was one
Yep.
like values are usually associated for the same activity adopted parents. Is that true?
Values, values and that kind of thing may, of course, the environment has a huge impact, but we're talking about traits that are going to be more influenced by genetics, so more of the biological components. But you could even argue, and I'm going to show you a little clip in a moment of these two twins who were separated at birth, and then they met later on. There are some differences because, of course, the environment does have some impact. But have you ever heard of the, I can't remember the two names of the two Jerrys, I think it is. And they were both firemen, they were both, all this kind of stuff. And did I tell you about those before? Yeah, where they were even divorced at the same age. Like they're both 45 when they got divorced, and people said, "Oh, that's ridiculous." You know, they both smoked the same cigarettes. They both drank. They're both firemen, and of course, you know, you think, "Oh, this is ridiculous. This is people just drawing at straws here." There's no such thing as a gene for divorce or a gene for, you know, smoking or a gene for drinking, but there is, because if you're a horrible personality, we call it the SOB gene. And you both have it, then of course you're not going to be getting along with people in a relationship, and that could lead to divorce. Or if you're very biologically reactive, let's say you're a stressy kind of person, that's the central nervous system, in particular the autonomic nervous system, I should say. And so you become very upset or you react to environmental stressors. And so you self-medicate by drinking or smoking, right? And that would be an outcome of a genetic basis. So it could be the same in both twins. So you would argue, yes, it is a consequence of a gene, initially. So these adoption studies where you have the two twins is the best way to do it. I'm going to put on the little clip here of the two twins. I wonder if anyone's ever seen this before. I want to put this on to see if anyone has ever. These are two twins, two twin babies. At some point. You gotta be kidding me. I think it was all about the missing sock. Unbelievable, right? This is why we're making that equal assumptions is a big assumption, because these two twins have been together in the womb, maybe even the same placenta, and I mean the way that they are connected, no wonder they're so close throughout life, right? I mean they're having no doubt a conversation, right? What's going on is Piaget's schemes, I guess, but nonetheless, this is huge.